Hi friends, in our lesson today, varying linear motion, and uh, it is the name given. It is the name given to the movement of an object with variable acceleration acceleration um, in this motion displacement motion displacement motion displacement velocity and acceleration are functions of time. Depend of the time to displacement, motion displacement, and velocity. And the first derivative of the position equation, the first derivative of the position equation of a moving object with respect to time gives the velocity equation, and the second derivative gives the acceleration equation. And all of this equation depend on the time. For example, our position equation depend on the time is occurred to this one, Bt plus C, and that's equation of motion. And if we want to find an velocity equation depend on time also, that's derivative to the position to time. Yes, derivative of the x with respect to time. And what is the meaning of this term? This term meaning of it tell us how we will derivative to term. In here we are derivative to time. That's the meaning of this one. We will derivative to time. And we want to find the acceleration equation, equation depend on the time. We take the second derivatives to motion equation to time, and the other ways to find the acceleration equation depend on the time. Take two derivative of the velocity with respect to time. Take the position derivative of velocity with respect to derivative the velocity to respect to time. That's also meaning is derivative. Derivative of velocity with respect to time. Yes, that's all meaning is this one. Let's looking on the example and try to completely understanding to this varying linear motion. That example is the equation of motion of a materials point moving on a straight line is given by the relation x depend on the time equal and minus 2t to 2 plus 5t plus 6. Since this expression has t second and x meters what will be the speed of the object at the end of the third second. Yes. And that's the soul of this example. Firstly, writing here to our equation, motion equation, depend on the time. Yes, that's also our motion equation. And we want to find speed, and at the end of the third second. Firstly, we must be to find speed or velocity equation. What can we find to this equation? Derivative to the moving equation to respect to time. Yes, and if we are writing here to our motion equation, derivative to respect to time, and we can find this equation's result is third t to 2 minus 2 multiplication 2 t and 5 multiplication 1 t to 0, and also here is the third and decrease to 1, and if we are decrease to 1, find to 2, and this one is multiplication to coefficient here. Yes, and this one is here and decrease to 1. Yes. And that's also 0, and we can find moving equation 3 minus 4 2 and plus 5. Yes, that's our moving equation. Yes, and in the questions asked to what is the speed of the object at the end of the third second? If we are writing here to third, we can find to end of the third second our object's speed or velocity. Plus 5, and that is the meter per second. Yes. What is the acceleration of our object at the end of the third second, we can find to this way. Yes. Acceleration depend on the time. Acceleration equation. We are take to derivative depend on respect to time, and that's also velocity and speed of the respect to time. And if we are writing here to our find in here the find to velocity equation, and the derivative to time, we are find to our acceleration equation depend on the time, and 6t minus 4. And then ask in the questions at the end of the third second to acceleration value. Yes, and minus 4, we can find to acceleration value meter per second square. Yes, and that's easy to varying linear motion is easy. And now the new one is forces of friction, and from now we will talk about the frictions of force, which is the one of the most important factors that create the movement, and that's our forces of friction. Forces of friction. Yes. When an object is in motion, either on a surface or in a viscous medium, such as air or water, there is resistance to the motion because the object interacts with its surrounding surroundings. We call such resistance force of frictions. Force of friction. Force of friction. Force of friction are very important forces of friction are very important in our everyday lives. Important in our everyday lives. They allow us to walk or run and are necessary for the motion of weld vessels. Weld vessels. Let's look into these figures and between this mass and the surface are friction coefficient. And friction coefficient is showing to mu. Friction coefficient. Yes. In here, this mass not moving, stable system. Stable system, and this mass value is, for example, m, and that's also apply to the the gravitational acceleration to an force, the gravitational force, and the gravitational force value is m, mass value, and multiplication to gravitational acceleration. Yes. And we can find to our mass gravitational force applied to gravitational acceleration to force, and if we are apply another forces, but this force equal to friction force, there is no initial speed, the system is stable, and that's also frictional forces. And also the frictional forces is the opposite direction of the force. In the stable system, frictional force opposite direction to force. And if our mass or object moving to force's direction, that's also moving system, that's also moving direction, our gravitational force is the same direction of the gravitational acceleration direction, and we can find to mass and the gravitational acceleration, we can find to gravitational force, and our object mass is m here. Yes. And also there is a frictional coefficient between two mass and the surface. In this stable system, the object is not moving, stable, and this frictional coefficient is called is the name of the stable static coefficient friction. And if we are looking to moving system, between two object and the surface, coefficient friction is the name of kinetics friction coefficient. Yes, that's also kinetic friction coefficient of friction, or friction coefficient, and the static friction coefficients. In general, static friction coefficient bigger than to kinetics coefficient friction. In general, sometimes equal to this one. And if we are looking to graph for easy understanding to these two events. Yes. That's also force and frictional force. And yes. But firstly, looking at the moving system. In the moving system, frictional force is the opposite of the moving direction, and the moving direction is the right side, and our frictional force is the opposite side. In here our frictional force is the opposite side of the moving direction. Yes. And stable system, in the stable system we can find the frictional forces if we are the 90 degree, we can find to G plus ms, static frictional coefficient. And also this one is the forces, and the unit is Newton. And we can find also the moving system frictional forces in here, G plus M kinetics, mu kinetics, and also this frictional forces unit is Newton. But also G has gravitational force, and gravitational force unit is Newton, and that's kinetic frictional coefficient unit is non-unit, unitless. And also in here gravitational force is Newton, and the frictional forces unit is Newton, and the static frictional coefficient unit is unitless. Yes. And here, looking here, we know to static frictional coefficient bigger than the kinetic frictional coefficient, and our graph is the one. That's also best bigger value for frictional coefficient, and then our object when to moving on the surface, frictional coefficient value is degree, degrees, and then occur to stable, and that's also kinetics frictional force, and the kinetic friction coefficients multiplication to reaction forces. Reaction force is opposite of the gravitational forces, and showing to n, for example, showing to n, that's also reaction forces. Reaction forces. Reaction forces is opposite of our gravitational forces, and our object press to the surface, and the surface reaction of these forces, and we can find these forces, reactional forces, and the reactional forces to showing to this one, and the reaction forces has a right angle on the surface. And also, if we are showing to reactional forces has a right angle with the surface, and we are using to here to n. So our gravitational forces not has a right angle always not has a right angle, but the reactional forces always has a right angle. So we can use the reactional forces when we want to find the kinetic friction forces. Yes. And this is the reaction forces. And that's also static region. In here is static region, and here is kinetic region. In kinetic region, our object has a speed, has a speed. And also we know to this one, static friction coefficients bigger than the kinetic friction forces. In here to static friction forces equal to our forces in here, and our frictional forces in here, opposite direction. And the following experience the following empirical laws of frictional summarize summarize the experimental observation. Observations. And the first experimental observations is the magnitude of the force of the static friction between any two surfaces in contact can have the values. And static frictional forces less or equal S and reaction forces. Yes. And that is the meaning of coefficient of static friction. And reaction forces, surface reaction forces, and that is frictional forces, static frictional forces. Yes. And the magnitude of the force of kinetic friction acting between two surfaces is kinetic friction forces equal kinetic coefficient of kinetic friction multiplication to reaction surface reaction force, and that's also reaction force. And the meaning of coefficient of kinetic friction, and the meaning of kinetic friction force. Yes. And and the value of mu kinetics and mu static depend on the surfaces, but mu kinetic is generally less than static friction coefficient. Typical value range from around point 0.03 to 1.0. And the direction of the friction force on an object is parallel to the surface with which the object is in contact and opposite to the actual motion for kinetic friction. Or the impending motion, static friction of the object relative to the surface. And if we are looking to kinetic or the static coefficient, frictions of coefficient for some materials, coefficient of friction for some materials and writing here to materials name and writing here to frictional values, and the first one is given to static frictional coefficient, and the second one is are given to kinetic coefficient friction. And if you are looking here, and steel our coefficient value is 0.74, and the other is 0.57, and also static frictional coefficient and also kinetic frictional coefficient has not a unitless, and unitless. Yes, that's important. Yes. And copper and steel, .53, and that's 36. And glass on glass, glass on glass, .94, and the kinetic 0.4. Teflon and on Teflon equal to .04 equal of the static and the kinetics friction coefficient. Synovial joints in humans so less the others, and the static is 0.01 and kinetics is 0.003. Yes. Also, that's our coefficient of frictions values. Yes. And now let's look into this exercise. And we have a slope of surface, and the angle of this surface 37 degree, and there is a mass, and M1, the value of this mass 2 kilograms, and also there is another mass 2 and the value of this mass 7 kilograms. And there is connect to these two mass between with cord. Cord. Yes. If there is no friction coefficient between the mass and the surface, yes, mu equals 0 and also mu equals 0. And firstly, we must be to gravitational forces, and the gravitational forces showing to this direction, and the value is multiplication to gravitational acceleration. And if we are taking to gravitational acceleration is 10 meter per second square, we can find to this gravitational forces, and our gravitational forces has two projections, and the first one is the this direction, and the other one is this direction, and also has a right angle, this projections. And these projections occur to our reaction forces in by surface and n. And let's find to these angles. Let's looking here. Has this angle is right angle and 37 degree, and here to 53 degree, and also opposite of 53 degree, and has a right angle, and this angle is 33 degree. And if this angle has a 33 angle, this projection has, for example, gx, and g multiplication to cos 33, and gy projection is g multiplication to sin 33 degree. And if we are taking to sin 33.6 and cos 33 equal to sin 53, 37 equal to sin 53 and equal to dot 8, we can find to here to, and value is 2 and multiplication to 10, 20 newtons to gravitational force, and equal to are 20 multiplication to cos 33 equal to sin 37 equal to sin 53. Sin 53 equal to 8, and the value of the x projection of the gravitational force is 17 Newton, and this one is 20 multiplication to 0.6 and equal to y projection of the gravitational force is 90 equal to this one. Yes, and then let's look into second mass. And firstly, draw to the gravitational force direction, and this one, and mass 2 multiplication to gravitational acceleration. And here the value of the mass 2 multiplication to 10 and 70 Newton to second object gravitational force, and this has a right angle here, and the value of this angle is 53, and also this angle we can showing the other color, and the value of this angle is 53 angle, and there is two projections of the gravitational force, and the first one is this direction, and x we are called to x, and the other is two gravitational forces y projections. Yes, and the x projections has a right angle, and this angle value is 37 degree. If this angle has a 37 degree, we can find two x projections is g multiplication to cos 33 and the gravitational force y projection is g multiplication to sin 33. Yes, and the value of the g forces, g2 forces x projection is 70 and cos 37 equal to sin 53 and equal to 56 Newton, and also equal to equal to 42 Newton. Yes. And if you are looking here in this system, these forces parallel to surface to 42, and this one is this forces value is 13, and 42 bigger than the 13, this system moving to this direction, and that's our moving direction. And now there is no friction coefficient on the surface between two our object, and let's just look into y projection of our system. And firstly, let's look into net forces of the first mass. If we are find to net forces of the first mass, and on the T forces on the on this on this chord, that's also our chord. On the chord occur to T forces, tension forces, and if we are looking to firstly looking to one object for M1, T tension forces bigger than the G Y GY projections, and if we want to find two net forces, minus 2 G Y for one object, that's also 1 and 1, yes. And we can find in here two net forces for M1, and if we are writing to value of the G1Y, and T is, we don't know the value, and if we are writing here to this value is this one, and F1 net. F1 net is also all of the forces is equal to m multiplication to acceleration of all the forces equal to this equation. And Now we are writing here to this one. So the F1 net also force, and M1 plus A. A is also our system acceleration. So connect to the M1 and to M2 object, connect to the others. So has a M1's acceleration equal to M2's acceleration. And that's our first equation. And our first equation is M1's value is 2 multiplication to A. That's our first equation. Yes. And let's look into second object for M2. And if you are looking to here now, G2Y projection bigger than to T, tension on the cord. So we can, if we want to find to net forces on the second object, we must be writing to G2's Y projections minus T tension forces, and we can find to second on the second object net forces, and we are find to this value, but this value is in here, and the value is 32 minus T tension forces on the cord equal to M2 net also equal to forces M2 multiplication A, and M2 values is 7 kilograms multiplication to A, and find to our second equation. If we are total of if we are total of these two if we are addition to first and the second equation, and our first equation is T minus equal to A multiplication I, our first equation, and the second equation 32 minus T equal, yes, and if we are addition to this two equation, and can find the 30 equal 9 dot A, and our system acceleration value is 33 meter per second square. And if we are writing on a writing to this value on the on a equation, for example, first and also to t minus 20 11 equal 33, and we can find two tension forces on the cord equal to 18.66 Newton. And the tension force also is force, so its unit is Newton. Yes. In this question, there is no friction coefficient, but if we are give a value of the friction coefficient, we can changing of this question, and let's looking also again. I'm copying to these questions. Copy and paste here. Yes. And we are I'm given a friction coefficient, for example that's 2, yes. And that's important are the moving direction now. So our surface has a friction coefficient, and the opposite direction of the friction forces for first mass, and our first mass friction forces is this direction, opposite of the moving direction, and the value of reaction forces multiplication to friction coefficient. Yes. And our reaction forces equal to this one and equal to x1 or x and 1, and here and 2 is equal to the 2's x projections, and also vectoral magnitude. And here our first frictional forces equal to 19 multiplication to mu. Mu values is 0.2, and we are now to what is the value? We are now calculate to this one. Yes, 2.3.2 Newton, and the first mass frictional forces. And let's look into second mass frictional forces. The second mass frictional forces also direction is the opposite of the moving direction, and our system moving to right side, and if we are looking to second mass frictional forces also the direction of the opposite of the moving direction, and that's also second mass frictional forces equal to and 2 multiplication to mu. Mu is frictional coefficient value, and frictional coefficient value unless units, and the value is 56, and multiplication to 0.2. And what is the value of this one? Yes, sorry. And what is the value of the second object frictional forces is equal to is equal to 11.2 newtons. Let's look into first object net forces for M1 and now has a this system has a frictional coefficient, and the value is that 2. Yes, and let's look into first mass, and if we want to find the first mass net force, and the moving direction has a right side, and the t is bigger than 2 g1 y projections, and 1 frictional forces equal to F1 net forces. And if we are writing to value of this term equal to this one, and 3.2 equal to m1 dot a. A is our system's acceleration value, and t minus 8.8 m1 is m1's value is 2 kilogram, and that's our first equation. And if we are looking to m2 mass, if we want to find object ones on the net force, and the moving direction is the right side, and the big G2 Y projection bigger than the other one, and minus T tension forces on the cord, and minus F2 friction forces. So friction forces direction is opposite of the moving direction, and we are find in this equation to F net second F net forces, and this term's value is 32 minus T tension force, and also second friction force value is that 2 equal to m2 multiplication to our system acceleration, and our this mass value is 7. So our second object mass value is 7, and 32 minus equal to 30.8 minus T equal this one, and also our second equation, and addition to this two equation, and 30.8 minus T equal this one, and if we are addition to this two equation, and we are find to 22 equal and a a finding to 2 meter per second square. If we're writing in the first or the second equation to the acceleration value, yes, plus, yes, t equal Newton. Yes. That's our final tension and acceleration value of our system. Yes. Sorry, that is not true. So that value is yes, and there's changing to this value. And also change here, and the results of this equation is sorry, also changing here 30 to 8 minus 15.2 value is 15.6 and divide 9 1, yes, and changing here again 1 2 multiplication to 1, yes, plus 15 and 2 equal newtons. Yes, that's true, I think. And yes. And the other subject is yes, I'm finished here. The other subject is movement in 2 dimensions. movement into dimensions.